Welcome back. It's another review video. Last time we looked at Venn diagrams for statements, and this time we're going to be doing Venn diagrams for arguments. We're going to be reviewing those, reviewing the rules for doing those, as well as doing two examples so that you can see how to apply the rules to actual cases. And I'll be laying out the rules as we go through those two examples. So an important handout that I handed out back before spring break and all this craziness that's been going on and the online stuff. I'll put a let's see, I'll put a name down there. It's categorical for categorical arguments, and I'll put a little video insert to see how to access it. It'll be in the modules at some place below where this video was linked, as well as you can go to files, of course, and then select the notes folder, and from there at least right now it's the last PDF on there, categorical arg. It's a good handout because it has some more detailed rules about how to do this. All right, let's go ahead and jump in. So let's start with just a circle, and you got to draw your top circles. On the top you want your two circles, and then the bottom you want one circle. Remember, it's always good to draw them the same way each time, as well as label them the same way each time, so you don't get confused. As I've said, I've gotten confused many times because I try to do stuff in a different orientation, and you don't need that extra source of confusion. So how do we label? Well, it's helpful to know the names of the different terms that occur. So we have subject, predicate, and middle terms. So these are the types of terms. Subject and predicate they're referring to the subject and predicate of the conclusion. So subject of the conclusion is going to be animals. It also occurs up here. So our subject term is going to be animals. Our predicate term, let's see, rocks. So we'll go ahead and put that there. And middle term, well, rocks also occurs up there. Our middle term is the term that does not occur in the conclusion. So that's going to be sentient things. So those are our terms. Now to label our circles, we want to always label them the same way. Here's, I think, the best way to do it. Just as the subject occurs on the left, predicate on the right, just keep that orientation for the top two circles. So we have our subject term and predicate term circles, and the middle one's going to be this one. And to make things even clearer, let's now add the specific terms from our example in color to the circles. Ah, nice. All right, so we've done the first thing on the list. We have drawn our circles and labeled them correctly. The next thing we're going to do is diagram our premises. So our first premise, no rocks are sentient things. For that, we're going to just be looking at the circles rocks and sentient things. So that means for now we're going to ignore the other circle about animals. So let's do that. All right, successfully ignored. So no rocks are sentient things. That's saying there's nothing that is inside the rock circle that's also inside the sentient thing circle. That's empty. And to indicate empty, we're going to shade in the areas that are supposed to be empty. So we're just going to go ahead and shade in everywhere that would be a rock and a sentient thing, because it's saying there are none of those. And since we're ignoring our animal circle, we're just looking at these two circles, and there's nothing that's inside the rock circle that's also inside the sentient circle. That's all empty. Awesome. So that's our first premise diagrammed. Our second premise now is what we need to diagram. And for that, we're going to be looking at the animal circle and the sentient circle and ignoring the rock circle. So let's switch that up. So we're going to look at animals and sentient things. This is saying that everything in the animal circle is in the sentient circle. So that means everything that is in the animal circle that's not in the sentient circle, well, there's nothing there. That's empty. So we shade it in to indicate that. And now we have successfully diagrammed our premises, so we're going to move on to the next thing, and we're going to be asking, does our diagram of the premises tell us that the conclusion is true? So let's rearrange what we ignore, and we'll set things up to diagram the conclusion off to the side, because sometimes, in fact, I often do it when I'm not sure, just to see what the conclusion looks like diagrammed all by itself. So let's do that. What would our conclusion look like if it was also diagrammed on our diagram? Well, for that, we're just going to be looking at the animal circle and the rock circle, because those are the terms that occur in the conclusion. We're going to see if the information, the diagram of our conclusion, is already contained in our diagram of our premises. So off to the side, we have a separate diagram for our conclusion, just so we can see what it would look like for the information of the conclusion. So no animals are rocks. Animals and rocks, that's saying there's nothing that's inside both the animal circle and the rock circle. That's empty. So we're going to shade that in, and that's a diagram of the conclusion. Okay, is this information already contained in our diagram of our premises? In fact, it is. The animal and the rock circle, ignoring the other circle, we already have the information that this is empty. There is nothing that is inside both the animal circle and the rock circle. That's empty. So that means that our original argument is valid. If the information is of the diagram of the premises is already contains the information of the conclusion, then you have a valid argument. If it did not, then that would be an invalid argument. But this is valid because our diagram of our premises contains the information already. Right? So the idea of why this works is that validity for this argument would mean that if the premises are true, then the conclusion has to be true. Well, if it's valid, then what did that mean for Venn diagrams? It would mean a picture, a Venn diagram picture of our premises would already contain a diagram of our conclusion within it. If that's what it would be if it was valid. So that's the correlation. Truth guaranteeing validity corresponds in the diagram to a picture of the premises includes a picture of the conclusion within it. If it fails to include that picture within it, then it's not valid. That first example was pretty easy, but there is a twist when you have a particular statement like this one, especially when it comes first. So let's go ahead and do this example to see what to do in that case. All right, what is our subject and predicate terms? It's going to be subject is going to be what? Starfish, because it's the subject of the conclusion. Starfish also occurs up there. And for this one, I'll go ahead and draw the circles in the corresponding color. So subject of the conclusion, that circle is the one that's going to go on the left. And then the predicate term of the conclusion, on Earth, or things on Earth, we'll do that in blue. On Earth, it also occurs right there. And then the middle term is going to be in the Pacific, or creatures in the Pacific. The middle term being the one that does not occur in the conclusion. So we'll do that in green. And we'll go ahead and label them just to be extra clear. So we got starfish up here, and on Earth, and on the bottom we got creatures in the Pacific. All right, so now we need to start. We've completed the first thing, right? We've drawn our diagram, our circles correctly, and labeled them correctly, doing it the standard way. Now we need to diagram our premises. So, first premise, some starfish are not creatures in the Pacific. Here is where the rule comes into play. Here is the new rule for when you have a particular statement mixed in with a universal statement. In that case, what you want to do is always diagram the universal statement first. That'll help things out a lot. If you do, in fact, it won't just help things out. You can get the wrong answer sometimes if you don't follow this rule. So when you have a mix of a universal statement with a particular statement, both occurring as premises, you always want to diagram the universal one first. So let's do that. Premise 2 is the universal. All creatures in the Pacific are on Earth. We're looking at the green and the blue circle. So green circle, blue circle. It's saying that all the things in the green circle are in the blue circle. So that means all the things in the green circle that are not in the blue circle over here, that's actually empty. There's nothing there. All the things in the green circle are in the blue circle. So everything else in the green circle, that's actually empty. So that's premise 2. Now we go back to premise 1, our particular premise. Some starfish are not creatures in the Pacific. So it's saying some things in the red circle are not in the green circle. So we're looking at red and green. Some things in the red circle are not in the green circle. So that means we're going to put an X somewhere, right? Because it's a particular. So we want to put an X to represent at least one thing. In this case, starfish. At least one starfish is not in the green circle. It's not in the Pacific. So we have two areas that count according to that. This area right here is inside the red circle and outside the green circle, but also this area right here is inside the red circle but outside the green circle. So what do? Well, we are going to put the X right on the line. And when we put an X on the line, that means there is something in this area or in this area or both. We just don't know. It's an either or. So X on the line, that's the same thing as an either or. So either this or either blank or both. Um, that's all the information that premise one is telling us. It's saying some starfish are not creatures in the Pacific, but it's not saying anything about whether they're starfish, those starfish are on Earth or not on Earth. It's not about that. So we have to leave that open. Either this side or that side or both, right? We don't want to pick because then we would be adding information to our picture, but we'd be adding information to the picture that's not already in the premises. So that's not what we want to do because our diagram is supposed to diagram the premises that occur. We don't want to make a choice and add our own choice in there. It's supposed to be a picture of our premises. So good. So with that new rule, always diagram universals before particulars, we can now move on to seeing if our diagram of the premises tells us that our conclusion is true. Does this already contain the information that would be there if our conclusion were diagrammed with it? Well, what would a diagram, a picture of our conclusion look like? Well, let's go ahead and draw it down here. So we have starfish in Earth circles. So here's our starfish circle, and we need an on Earth circle. And our conclusion is saying some starfish are not on Earth. So there's at least one thing that's inside the starfish circle, inside the red circle, but outside the blue circle, the Earth circle. So inside the red, outside the blue, that's right there. Okay, if that's what our conclusion, a picture of our conclusion will look like, is that information already contained in the diagram, the picture of our premises? Well, no, it's not, because we would need something that's inside the red circle, but outside the blue circle. But we don't have an X inside the red circle that's outside the blue circle. We have half an X, but that's not enough. Because, of course, the X on the line, remember, it's either or, either here or there. It doesn't tell us for sure that there is something that's in red and outside of blue. It just says there's something that's inside of red, and either it's outside of blue or it's inside of blue, or maybe there's one on each side. There's one that's outside, one that's inside. It just doesn't tell us. It doesn't have that much information. So our picture of our conclusion actually has some information that is not already contained in the picture of our premises. It goes beyond them. So the corresponding thing to gather about our argument that now our picture has told us is that if our premises are true, well, that doesn't guarantee that the conclusion is true. A picture of our premises doesn't already have the information of our conclusion. In the same way, our premises don't guarantee our conclusion. So it fails to guarantee, so it's invalid, right? It does not guarantee truth. True premises here would not guarantee truth. Just like the picture of our premises does not already contain within it a picture of our conclusion. All right, that's all for this video, but if you want more practice and to do more of these, which are the same type of problem that are going to be on the next exam, Go ahead and check out my other videos that I'm going to be uploading. It'll be the extra videos. In those extra videos, for Venn diagrams, I'm going to be doing some extra problems. So if you want extra practice and to get prepared for the exam, I'll be going through more examples so you can do them along with me, and get that extra practice in. As always, any questions you have or any problems you have, don't hesitate to contact me. And as always, thanks for watching. I'll see you in the next video.